Thank you. Welcome to my channel. Today we have the remove nth node from end of the list Leetcode question. So the question goes like, given the head of a linked list, remove the nth node from the end of the list and return its head. The question is pretty much self-explanatory, but maybe to more clarify on the question is that given the head, so this is our linked list, we need to remove the nth item from the last node. So as you know, for example, we are given this node which has 1 up to 5, and we are asked to remove the second element from the last node. So the last node, so counting here, we have to remove the first element and the second element, and then we have to remove 4, which give us a list like this, and we have to return the head. So when we are given 1 and we have to remove 1, then we return an empty node, and then which will be the head, and also the same. Now, how do we go about it? There are 2 ways. So the first way would be to have an array. You initiate an array, and then the array, you give it all the nodes, and then you calculate the position. So for example, it will be at an index. If you have this inside an array, it would be you have 5 items, and you need to remove the 4th item, which will be at an index of 4, 0, 1, 2, 3, which will be at an index of 3, and then yeah, you have to remove that. So that's a possibility that you can do. And then you can say, since you need to remove the index of 4, you can say you get the length of the array, you remove n, which would be the length of the array would be 5 minus n, which would be 3. So you can say that you iterate until you navigate the list. So if you have the array, then you know that the position to delete is the 3rd position, and then you say 0, 1, 2, 3, and you remove it. So that's one case, but the problem won't be that you will use the memory of O of n. Then the solution would look something like this. So if we were to use the array, we would have a solution that looks like this. So we have our array, then we initiate a temporary element so that we can put all the elements into the array. Then we calculate the position where we want to delete, which is the length of the array minus n. And what we do is we say, oh, you can also do this with the count and all of that. And then we say our count is equal to 0. We again put our temporary element into the head, so that we can now traverse through the list again. But we first check if the position we want to delete is not 0. So when it's 0, it means we have to delete the first element, and that's what we do. No, that's what we do here, because we have to delete the first element, which means we shift our head to the next item. Or if there is only one element, it means the 0th, then return none. Otherwise, which is this case, we are going to return otherwise, which is the kind of length case we are going to initiate, and then once we get to a counter, which we had initialized here, once we get to a counter where the counter plus 1 is equal to the position. So once we get to this element where when the counter is done, it will be when the counter incremented with 1 is going to be equal to the position that you have to delete, then we are going to delete it basically. So we are going to delete the element. We said the node that we have to delete is equal to the next item, then the next item should be pointing. So the current item should point, its next should point to the node that you want to delete, the next item of the node that you want to delete. And then this step is really not necessary. Yeah, so we said the delete node should point to none. Yeah, then we continue our way. Yeah, and return the head. If you do this, it will work. It should be able to work. Yeah, you see this works, but the problem, as I mentioned, is that we are using O of n memory. So the best solution would be to do something like this, which is basically you initiate 3 pointers. So we have 3 pointers, and the first pointer is the left, which starts from the first element. The right, that also starts from the first element, and the previous of the left, so it's the element that precedes the left, so which is going to start here, which is none. We don't want to put there anything. And then what you're going to do at the first step is we are going to move the right pointer to have like to be in a range where that there should be n, where we have to move it n times. So yes, we have to move it n times so that we know so for example, at the start it's going to end up to be here. Yes, it's going to end up to be at 3, and then because we have to have 2 elements. Yes, then from there, once we end the so okay, sorry, I got carried a bit. So once we get to this, so the right is here, the left is here, and the previous element is here. What you are going to do is say, okay, now previous, every time we have the right, which means the right is not yet at the none element, so it's not at the end, it's not at this end. Yeah, so we are going to tell like previous should be equal to the left, because we want to shift the left. We shift the left and then we shift the right. Now once we've finished shifting, it should be the previous element will be here, the left element will be here, and then the right will be here. Then that's to mean that if we do not have a previous element, that means we should remove the first element, which will be here. It means the left will still be here. So what we do, then we have to return the head.next. We have to return the next element, the next node. Yes, sorry. Then also if the previous dot next, so this means the left is here, the previous element is here, the left is here, and the right is here. So we need to shift our previous left. Yes, our previous left, because this is the one to delete. We need to assign it to this one, which is the previous element. Then left dot next, it points to the left dot next, and then the left dot next is we want to remove this link, so it goes to none. Then you return the head. Yeah, so once you do this, yeah, everything works, everything is good, and then yeah, you can submit. This allows us to use O of 1 for the memory and O of n for the time complexity. Yes, thank you. Oh, sorry.